Welcome to week 5, where we're going to cover equilibrium and free body diagrams. So the following question says, determine the horizontal and vertical components of reaction for the beam loaded as shown below. Neglect the weight of the beam in the calculations. So as you see, we have a beam that is pinned at point A and pinned at point B, and we have 3 different forces acting on it. So before we move on to solve, we need to review the rotations. So whenever a beam or something ends up rotating clockwise, so clockwise would be this way, it's a negative rotation. Whenever it rotates counterclockwise, it's a positive rotation. So let's say we pinned the beam here and it was free on this end so it could rotate, and it started rotating like this. That would be clockwise, so it'd be negative. If we pinned it here and it rotated like this, then it would be counterclockwise, so it'd be positive. It's always important to remember your directions. So the first thing I want to do is write in my fx and fy, so we're going to have to decompose this into components, and then the vertical and horizontal components that are unknown that I want to find are ay, by, and bx. Now, you're probably wondering, why is this one only a y component and why is this y and an x? Well, these are 2 different types of pins. So in this type of pin, you only have a y component, and this type of pin, you have a y and an x component, and they're definitely 2 different types of pins. You'll read more about them in your book. But the other thing is, I'm drawing these arbitrarily. I'm drawing my ay up just because I like it up, but you could draw it downward. Same here. You could draw this down, you could draw this to the right. It doesn't matter. So the first thing I do is I find my fx and fy component using sine and cosine. I hope you guys know how to do that at this point. If not, I'm a little bit worried. So from there, I do the summation of all the x components in order to find bx. Because we only have fx, and we know what a fx is, and we have bx. Those are the only x components. So I have positive fx because it's pointing to the right, minus bx because it's pointing to the left, equals 0. So in the end, bx equals 424.26 newtons to the left. So because I got my answer to be positive, it means that the way I drew my force to begin with is the correct direction. Let's say I ended up with a negative 424. It means that the way that I drew my force is not the correct direction. It should actually be the other way. But because we got positive, it's the exact same way that we drew it. Moving on from there, I want to find ay. Now here I have to do the summation of the moments. And I choose to pin my beam at point B and do all of the moments about point B, because there are 3 different forces here, one of which is unknown, but there's 3 different forces here that we can completely eliminate and ignore in our calculation if we pin it here. If we pinned at point A, then we would have to consider all 3 of these forces, so that would just make things a lot more complicated. So I'm pinning at point B, and I start with the outermost force. So I have negative ay times 7 meters. So this is the 7 meters. It's negative because it would cause a clockwise rotation. Then I move on to fy. So positive fy times 5 meters. It's positive because if you think about it, it'll start pushing downward and it'll cause a counterclockwise rotation. Then I have negative fx times 0.2. So it's negative because, once again, if I were to push here, it would cause, it's kind of hard to visualize, but it would cause a clockwise rotation. So that's why it's negative. And it's only 0.2 meters away from the axis of rotation. And then plus 100 newtons times these 2 meters. And the 100 newtons would cause a counterclockwise rotation, so they are positive as well. And in the end, I end up with ay 319.49 newtons. Because I end up with positive, it means that the way I drew my force initially is the correct direction, so it's going to be upward. And now we have ay, we found bx, all we have to find is by. And that's pretty simple now that we have AY. We just do the summation of all the forces in the Y direction. So positive AY minus FY because it's pointing downward, minus 100 because it's pointing downward, plus BY because it's pointing upward, minus 200 because it's pointing downward, equals 0. So then when I end up solving and plugging in everything, I get BY equals 404.77 newtons. Once again, it's positive here, so it means that the way that I drew my force initially is the correct direction, so it's going to be upward. So in the end, I found my AY, my BY, and my BX, and it's important to always note your units and the direction in which the force will actually point. So always, 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 units and direction. Some tips and tricks to remember is whenever you're going to calculate the moment or some of the moments, put your axis somewhere on a point with many forces, like we did here at point B. Because it's exposed to 3 forces, that means it'll just make our calculation more simple because we can ignore these 3 forces. The direction of rotation is also important. Is this force going to cause a clockwise rotation or a counterclockwise rotation? That will tell you whether you're going to end up being negative in the equation or positive. And also, like I said, direction of the final force. Is your final value negative or positive? Does that mean it's upward or downward, left or right? Those are very important things you need to pay attention to. And obviously, details, details, details.